All right, everybody, thank you so much for coming. Appreciate it. I know there's a lot of other things going on at the Heli-Expo, but this is going to be a bit of a unique discussion here. Up at the top here, you can see a URL, so these slides are posted there. Well, they will be posted there. There's some of them already, and then the final ones will be posted later. So this is our all-star cast of speakers. So each of us has about 5 minutes of points to make, and then we'll have hopefully 15 minutes of time for questions and answers at the end. So we're not talking about electric helicopters today. We're talking about electric vertical takeoff and landing aircraft, really fixed-wing aircraft that have the ability for VTOL operations. Sikorsky did a study several years ago on the Firefly concept where they replaced all the mechanical systems with electric power capabilities. And you see here at the bottom, these are all the different mechanical linkages and things that they took out of the aircraft in order to make it electric. So you can see there's quite a bit of weight and volume taken up by mechanical transmission systems. eVTOL has a potential to not only get rid of all the mechanical systems like that, but also the swashblade collective, all the complex rotor systems that the helicopter industry has taken to perfection, and replace that with multiple relatively simple propellers or other ways for thrusters. And really for efficient flight, with a fixed-wing aircraft, we can fly on the wing and have much better cruise efficiency, longer range, et cetera. And we believe that there'll be very, very low noise, and that'll make operations within urban centers viable. Also, no tailpipe emissions if for a pure electric, and reduced emissions for hybrid electric. So when we talk about electric VTOL, we're really not talking about electric helicopters, although there are some, and they probably have some missions that would be suitable for that. But just like when cars were invented, they weren't mechanical horses, although somebody in China actually built one. You're really talking about a new form of transportation, electric VTOL aircraft. So why now? Well, certainly advances in electric motors, batteries, computer modeling and simulation, composites, changes in regulations, and even more promising is a change in attitude with the FAA and even regulators around the world. Lots of new technology. Technology is a new thing. Investments in technology, high risk, high payoff types of technologies. You look at some of the things like Starman, where you have Elon Musk, not only inventing upending the entire automotive industry, but now is building a privately funded booster rocket that's more powerful than anything in the last 50 years since the Saturn V rocket. So all these new technologies or advancements in technologies and attitude has really enabled new configurations which facilitate new missions that helicopters, mainly the helicopters, aren't currently doing. 2 years ago at Heli-Expo, Lynn Tilden said something very insightful. She said something very similar again yesterday, and because she is, in addition to the CEO of MD Helicopters, also CEO of several automotive companies, noted about Tesla. It's really disrupted the automotive industry. We have not yet had a Tesla come in and change us and disrupt us like Tesla has done for the automotive industry. Well, really we have. It's the electric VTOL concept, or electric VTOL advancements. So just a bit about AHS. So we were originally founded 75 years ago this week in Connecticut as the American Helicopter Society. And it was to provide a forum for discussions within the helicopter industry, the manufacturers, the developers in industry, academia, and government, and founded just as the first American helicopters were being built. So it's a very similar time to today, and we've expanded to become AHS International and the Vertical Flight Society. Very similar situation today where we have this new technology, and AHS is helping to work with the manufacturers, the regulators, potential operators on electric VTOL aircraft. We've done a lot to change the industry and help the industry over the years. So we've saved NASA funding when NASA was going to get out of rotorcraft development. When they were shutting down the wind tunnels, we were able to help move those, transfer the ownership of that over to the DoD. We provided major foundational support to the Joint Strike Fighter program when that started. That's why I'm here. I was working on JSF, and AHS was a fantastic platform for getting out the vertical message at that time. AHS has been one of the leading advocates for the tilt rotor, V-22 Osprey, civil tilt rotor, and we lobbied to get the original language by Congress directing DoD to do a future vertical lift program. And we've been we've done a lot of work in the last 10 years to make sure that that support continues with more robust funding and to help keep the timeline moving along. And similar to that, we see electric VTOL as the next transformative technology, and so we're fully embracing this. Our technologists, our members have seen the promise of electric VTOL, and this is really going to happen. This is really incredibly transformative. So for the last 5 years, we've been having transformative vertical flight workshops and conferences. We have a lot of online resources. We have our evtol.news website with more than 50 companies highlighted on that and categorized and summarized what each of the companies are doing. We've been working with Uber since they announced at one of our events in September 2016 that they're working on this Elevate ecosystem. We helped collaborate on their white paper, and we're featured a lot in the first summit they had this past April. So Uber is developing an ecosystem. They're looking at the helipads, working with real estate companies, working with the EV charger manufacturers, cities, potential OEMs to develop and help give birth to this new electric VTOL revolution. We mentioned we had our Transformative Vertical Flight Conference last month in San Francisco. We have the video and all the presentations for that available online on our YouTube channel and on our website. And what you saw last month at this thing is about 350 technologists from industry, academia, and government, from NASA, from Army, the traditional rotorcraft OEMs, as well as new tech companies, Uber, Amazon, Toyota, Intel, others, innovative companies, new eVTOL companies that are developing, that are founded really just for this purpose, as well as the big OEMs. So this is really a comprehensive revolution from automotive, from the rotorcraft industry, from airlines, for all the big companies and lots of small companies that have seen the potential from the promise of electric VTOL. So here at Heli-Expo, you'll see some electric VTOL stuff. We've got the Bell Air Taxi at their stand. In our magazine, which we have available at the back, you'll see it's VertiFlight magazine, the magazine of vertical flight aircraft. You'll see lots of eVTOL aircraft that are being tested and flown today. At the Airbus stand, they've got their City Airbus. Terrafugia has a stand right near the Airbus. So they were recently bought by the Chinese company Geely, who owns Volvo and a number of other automotive brands, and they're investing in new transformative electric VTOL concepts. Joby Aviation, this was highlighted in a Bloomberg article on February 1st, where they talked about the pilot flew for 15 minutes, they did a 15-mile loop. The aircraft could fly at twice the speed of a helicopter and making about as much noise as a swarm of super bees. So I'm not quite sure how loud super bees are, but presumably it's pretty quiet. And this is just a side-by-side comparison of the four-seat Robinson R44 and the four-seat Joby S4. The military has also invested in eVTOL, and by eVTOL I mean pure electric vertical takeoff and landing aircraft, as well as hybrid electric. So DARPA has funded the Lightning Strike program, about $130 million of investment in this 6-ton, 12,000-pound hybrid electric vehicle. Aurora also has a concept they're developing for the eVTOL air taxi market. They were recently bought by Boeing. Volocopter in Germany has been flying for several years and has started now some pre-production aircraft. They've got an investment of $100 million recently. Lilium Aviation, also in Germany, got an investment of $100 million. They flew a two-seat unmanned prototype. XCI Aircraft is looking at a 1,000-mile range hybrid electric bizjet, and they've got about 58 orders for that so far. Z-Aero, which was recently nominated for the Collier Trophy, is funded by Larry Page, one of the founders of Google, and it's said he's invested more than $100 million. He also, another company, Kitty Hawk, which is developing a prototype, so the actual version, the production version will look much different than this, but another concept for the consumer market, and potentially when these become consumer products, that will help with urban air mobility and other applications as well. So as I mentioned, there's more than 50 different VTOL designs. These are all categorized and explained on our website, evtol.news, which I encourage you to check out. And finally, for the media, just a reminder, please don't call them flying cars. There are aircraft that are rotable aircraft or actual flying cars, like the Terrafugia Transition, which is now going into production. But unless you mean like the sense with the Jetsons, where it's something that is a vehicle that transports people, in that sense, okay, that sense is it may be a flying car, but it's not a flying car. Like, Uber's not going to come and land in front of your house to pick you up. That's not what we're talking about here. It's really more of an air taxi, air shuttle service. So with that, we'll go into our next speaker, Michael Thacker, the Executive VP of Technology and Innovation from Bell Helicopter.
Well, thank you. Glad to be here for Bell. We think Bell is really uniquely positioned to tackle this market. Bell has been changing the way people fly for over 80 years, with everything from the first supersonic aircraft to the jetpack, to the V-22 tilt rotor, which is the first aircraft and the only one flying today really that does the transition from vertical takeoff and landing to forward flight in actual operations with people on board. So the challenges that we have are also opportunities, in that there's a unique convergence of technologies coming forward today. And Mike hit on a few of them with hybrid and electric distributed propulsion and autonomy. What you see here is a pilot with augmented reality being able to interact, seeing what she needs to see from a display standpoint, situational awareness, whether she's heads up, heads down, wherever, and being able to control the aircraft with simple, intuitive means rather than traditional helicopter piloting techniques, which can be somewhat complex and difficult to learn. If you're a helicopter pilot, you know what I'm talking about. So this convergence and what Mike talked about shows that we're at an inflection point in our industry. The industry is going to change. And whether we have a Tesla, you saw a number of companies on that list that would like to be the Tesla of the aviation industry. But being incumbents in the industry and understanding what it takes from a regulatory standpoint, from an operational standpoint, from a manufacturing quality and safety standpoint, along with the basics of what does it take to fly and accomplish the mission, we have the opportunity today to move forward with the technologies as they're coming available. So for Bell, we're focusing on a few enabling technologies, not just for the air taxi model, but for all of the different applications which on-demand mobility represents for our industry. Again, we see this as an opportunity to truly change the way we fly, to change the way the world works, both in urban transport, but also in things like logistics, in things like offshore oil rig maintenance and operations. So there are a number of applications that, some of which have been traditionally performed by helicopters, many of which just don't exist today because either the technology or the affordability don't exist. For us to be able to tackle that market, we need a few things to be in place. We mentioned the key ones, the hybrid electric and distributed propulsion and the autonomy piece or the augmented flight, but you need a few things beyond that because affordability is a key. There are a few things that we have to do to make this work. It has to be cost effective so that we can reach more people, to bring the benefits of aviation to more people in more places around the world who today couldn't afford to take a helicopter across the city of New York. But tomorrow will be able to fly from Frisco and North Dallas to Arlington and South Dallas to visit their grandchild on a weekend, and it will make sense for them financially to do that, to not deal with the 2.5 hours of traffic getting through the central part of the city. In order to do that, we need new materials, we need a new approach to the design and the build of the aircraft to optimize for cost from the beginning. But beyond that, it has to be safe. And from an aviation industry perspective, we have always focused on safety. But we need to think about that in a new way. Because again, we're bringing people on board who are not aviation people. They're not people who have flown in helicopters. They need to have a sensation of safety, dependability, of comfort as they get in. So when you go to our booth, and I hope that you will, to experience the Bell Air Taxi, our point with putting that together and of debuting it at the Consumer Electronics Show rather than a traditional aviation show is to talk about how we work this from the inside out. How we make the experience for people who are non-aviation people an experience that is comfortable, that is familiar, and that is something that they can see themselves doing. So if you take that ride in our air taxi, you'll see what it's like to come in, to check in to a low security environment, be able to get on the aircraft, be able to fly across town in a safe, reliable, quiet, dependable manner, and get to your destination. And so we're trying to help people understand what that's going to be like, because beyond the safety and beyond the regulatory, there's a public acceptance issue that we've got to address. And getting more people familiar with what the benefits of aviation are and how that can make their life better is a part of what we as an industry need to do to get people to be accepting of the idea of many more of these flying over their urban locations. So I mentioned our air taxi experience. This is the embodiment of many of the technologies that are required to make this happen. We've been working with Uber to define what the infrastructure requirements might be. We've been working with the FAA and others on the regulatory environments, both for the vehicle itself and for the operational environment. We can't leave that behind. It's going to take the full body of the FAA working all of those issues together across all of the elements of the FAA to be able to make this a reality. But we believe the environment at the FAA is right to make that happen. We believe that the technologies that are needed to make this happen are converging today to make this a reality in the not too distant future. So with that, we're looking forward to bringing you all into the vertical century. Thank you.
Thanks, Michael. And we now have Mark Moore from Uber to give some insights into their vision.
I just wanted to start by saying I'm thrilled to be part of this panel, because if you look across all these different presentations, they are from our partners, right? I mean, even before I was at Uber, Mike and AHS were there building this eVTOL community with NASA as we were the pointy tip of the spear trying to figure this out and turn these technologies into being ready for this. To have Bell as one of our partners developing an awesome new vehicle is just fantastic. To have the FAA really facilitating this change, and to have GAMA there uniting these communities, right? I mean, because we know this is a big challenge, right? This is a multi-billion-dollar investment. But what I'm most excited about in our strategy is that we've embraced a collaborative approach, right? We know we can't do it alone. We need all of our participation for this new ecosystem, for this new emerging aviation solution to make sense. So in a nutshell, I just wanted to give you a couple visual cues of what we're doing. And foremost, we are all about offering large metropolitan areas a new choice in transportation. And this is not a niche transportation choice, but a new meaningful way to get across cities. So inherently we're talking about being able to serve hundreds of thousands of people in an urban area. And I know you go, oh my gosh, that's that's crazy. You know, you see a few helicopter operations happening today, and you go, how do you get there? And I guess the easiest way for me to give an analogy is, you know, Uber's only 7 years old, and even 4 years ago we were just a tiny little upstart of a company. But in the past 4 years, we've gone from Uber Black and serving a few people, and quickly evolved to over 65 million users per month. So this kind of transportation change can happen. And what is so really cool about the way that we've crafted this system is that it's very infrastructure light. And the beauty of that is that it can evolve quickly, right? It doesn't take decades to put the infrastructure in place. But by doing that, we've burdened the vehicle tremendously. These electric VTOLs need to be way, way better than helicopters across every single evaluation metric, whether that's safety, efficiency, noise, speed, you name it. We're talking about being multiple times better than what helicopters can do today. Now, the cool thing is, you would be crazy to say that you could do that unless there was a fundamental change in technology. And luckily, there's some wonderful technology frontiers that are converging to make these vehicles, to make this new urban aerial mobility real. And foremost among them are distributed electric propulsion, autonomy, but also fantastic new manufacturing solutions. And it's clear to me that we're going to build a bridge from aerospace, which does great things but tends to be really expensive, really slow, and build in very small production volumes, and get to this future, this bridge to the automotive world, where we get their kind of costs and manufacturing volumes with aerospace safety. So you kind of see the image there. I just want to again highlight, you saw a glimpse of the infrastructure solution. We're working with real estate partners such as Hillwood in Dallas, who is committed to putting the infrastructure in place for these skyports across the Dallas-Fort Worth area. Also, we've announced Los Angeles and real estate developers there. But I really want to highlight, it all starts with these feasible vehicles. So I'm just so proud to be associated with Bell, with Embraer, Pipistrel, Mooney, and Aurora. All are developing concepts that we will put on our networks. And I know you may say, well, why work across multiple vehicles? Because it really is kind of the Wild West in terms of vehicle approaches, and there is quite a bit of risk in these vehicles, but there's also a lot of opportunity space, and we realize that diversity of concept approach is a wonderful thing. So we're not about picking a winner early on, and in fact, we don't want just one winner, right? For a healthy new ecosystem, we need multiple winners. So we are committed to getting multiple manufacturers to this new aviation industry, and doing everything that we can for several of them to be successful. Just to give you an idea of a little bit of the concept that we showed in the video, most of our partners are not showing their concepts yet, but we very much wanted the public to understand what these vehicles are essentially embracing, how they're different. So you can see the inherent distributed propulsor nature of these vehicles. And why is that suddenly enabled? Because electric motors are essentially a scale-free technology. Whether they're 100 horsepower or 1,000 horsepower, they're still greater than 95% efficient. They're still power to weight as good as a turbine, and they're incredibly compact. They're very low maintenance, very high reliability, because essentially there's one moving part, bearings. So you can essentially get an idea here about the reason we need this kind of reference concept, which we've shared publicly. Anyone can have this geometry. In fact, many universities are using this to do studies with. But we need to know how to close the gaps to help accelerate our vehicle partners. So one of the things that we've committed to is developing an advanced battery so that these vehicles can be all electric. And the more I get into understanding these all-electric VTOL, oh my gosh, this battery is very, very tightly integrated to these vehicles. And in order to have optimal vehicles, you've got to integrate these batteries in optimal ways. And that means us working really, really closely as we bring these battery technologies forward to work really, really closely with our vehicle partners. Again, we're so excited because each one brings a unique experience, whether that's Embraer designing for very high utilization, very low maintenance, or Bell being the leader in vertical flight, fixed wing flight, as Michael mentioned. This is very much smaller aircraft. So Mooney has, a high-performance aircraft that they have expertise. Pipistrel, you may say, well, who's Pipistrel? And it's a small Slovenia company, but they are the one company in the world that is already selling electric aircraft. So they also have a unique experience basis to be bringing forward to this industry. Again, just a quick view of this future. We are so excited, again, to be working with our partners to enable it. Thank you very much for your time.
Thanks, Mark. And now we've got Greg Bowles from GAMA. There we go.
So I just wanted to kind of point out to everybody, aviation has been through disruptive changes, and we kind of think we're in one now. So if you look at this page, what you're seeing there is a car. So horse and buggies on the street, 1900, Fifth Avenue in New York City. There's one car with a lot of horse and buggies. 13 years later, there's the same street, and there is one horse. Right? So that's disruptive change, right? And that's kind of what we think is happening. We're seeing the verge of what will be a disruptive change in aviation. Here's an example. So glass cockpit in aviation. So in 2003, Cirrus Aircraft put forward the first production mainstream glass cockpit aircraft with the Avidyne installation. Within essentially 3 years, but this graph shows you 5 years, it swept through production. So 98 to 99% of all production became glass cockpits that quickly, because it was a technology that people, once they saw, said, yes, I need that. And that is what our industry became. So we don't doubt that we're seeing a number of these things. I'm going to dive into a couple of the technologies in a little more depth, specifically what we're calling simplified vehicle operation. So today, we've gone from the stage of the federated cockpit with lots of round dials and glass as we all learned to fly instruments a while back. And today we're in the integrated cockpit world, right? That glass cockpit I just showed you, where the aircraft coordinates things a little better. So the gauges are not all independent, they crosstalk a bit, right? But the pilot is still the central processor, taking all that information and coordinating what the aircraft's going to do. So the human being, or I sometimes call it the meat processor that we are, us pilots, sitting there running the switches and dials, that is what's sitting in the core of today's aircraft. So simplified cockpit is what we're on the verge of. So we're doing some work with a bunch of organizations and agencies, including FAA. How do we develop this simplified cockpit where the pilot is on the loop versus in the loop? Taking the pilot out, the pilot no longer being an integral part of that processing of information, but now being more of an overall role, supervising, making sure things are happening properly, with the ability to intervene in intelligent ways, not stick and rotor skills in the event of failures. And eventually front row seats, right? So that's where we're headed with autonomy. It's important to kind of look at this workload from the federated cockpit. If you think about it, fraught with human pilot error issues. We are essentially saturated. When I fly single pilot, IFR, glass cockpit, round dials, it's about all I can do. If I have an emergency, catching that event is going to be, I'm going to lag in doing that because I am saturated with tasks. On the other end of the spectrum, the human can start to do what the human's good at, and that's where we really get some of these safety improvements that are being discussed, and that's why this is so exciting across aviation. So we've done something called the deconstructed pilot, where we took what is a typical pilot rating, and the FAA has these buckets of skills that they train a person to become a pilot in, And so these are the skills, these are the chapters of training, these are the skills you must demonstrate that you're good at in order to fly safely. And what we've done there is we've shown where we believe automation is superior to the human at this point. So if it's more than halfway across, we think automation is at the point where it's as capable as a human in those areas. And so the idea is here is to start dialoguing about when is technology sufficient to really simplify that task. So one of these, for example, navigation. I think we would all say automation and navigation is definitely there, right? If you stick me somewhere and say, Greg, where are you? If I haven't been there before, I probably can't tell you where I am. I can maybe point to north if I see the sun. But automation instantly knows where it is, right? GPS, inertial nav, even built-in maps, right? With a built-in map in a database, it can instantly recognize where it is on the Earth. So there are many technologies through here to discuss, but that's where the conversation can happen, where we eat the elephant of automation one bite at a time. I just want to throw a little bit of praise to the FAA as I wrap up here. So if we would have looked at what it took to certify electric aircraft around the world back in the first quarter of 2016, this is where things sat. You couldn't certify electric propulsion really anywhere. There was a little bit of hope in China and Europe for sport aircraft, and we had a vague hope for small aircraft in those markets. In this last year, so third quarter, we did an assessment. The FAA rules now permit the certification of electric propulsion in the Part 23 rules without special condition, right? So the new rules embrace it. FAA is working on a path for large aircraft with electric propulsion. Engines and propellers are coming along very quickly too, with more dedicated standards and a path there. Certainly, we are excited to begin that work in the rotorcraft world, and I think that's probably where we'll start spooling up soon. But what you'll find is between the US and Europe, these abilities are starting to spread to other parts of the world as well. So that is a really fastly developing map. And a lot of that's due to the Part 23 rewrite. That was a wonderful effort. I won't delve in detail into that. But essentially, we've kept the safety objectives and we've moved the details of safety into standards. So the last thing I'll say as I get off the stage here is quantifying what these vehicles are. So Part 23 is this super flexible, really wonderful rulemaking package that can eliminate the need for a lot of special conditions and exemptions. So this aircraft is a Cirrus. It's a Part 23, Part 33 engine, Part 35 propeller. Very clearly fits well into what the original intention of an airplane was in Part 23. This is obviously a helicopter, a Part 27 helicopter, certified engine under Part 33. Smack dab in the middle, I would tell you that's something like the 609, right? Articulated rotors. It's truly a meld of a complex helicopter with an airplane, and so I would say that almost sits in the middle. So the question becomes, where does 23 begin and end? Where does 2117B fill the gap, and where does rotorcraft begin and end? And we need to have those discussions. So we would argue there are vehicles that are truly airplane-like with additional features, like a eVTOL that's been discussed here, that fly in the wing, can glide, can do these things, that fit kind of on the border there, that if we put them within 23, we make our regulatory life a lot easier, and so we would lean towards saying that should be done to limit exemptions and special conditions, and even to limit too many wide avenues of difference in 2117B, especially globally. It makes sense if we can fit some of these vehicles there. We should take advantage of that. So that's what I'll say, and I appreciate it.
All right, great. Well, our last speaker then is going to be Dr. Mike Romanowski from the FAA.
But I want to talk a little bit about where we've been going with the FAA. I think the rest of the panelists gave us a remarkable overview of why the FAA needed to change. And I want to talk a little bit about what we have been doing to change and how we look forward to addressing these types of vehicles and some of the other significant changes we see coming down the line in the industry. So first off, I mean, we do see the dynamics of growth in industry. Mike put up 50 companies that are pursuing aviation. That list has a lot of new entrants. Right? We've seen a dramatic growth in the variety of entrants, the variety of concepts that are coming to bear. That's linked with the technology changes, but also the market changes, the business changes. We've seen very clearly the expectation from the public that not only are we going to ensure safety, which is critical, we're going to have the right level of safety for the type of product that we have that is coming into play, but we're also seeing an expectation from the public that we are going to enable these capabilities to come online. And we've seen that dramatically over the last several years. But most fundamentally, each of the folks gave a remarkable overview of the types of technologies we're seeing, and that's frankly a subset of the technologies we're seeing coming onto play. And when we look at the former product-based regulatory structure, where we had groups of folks working on rotorcraft, we see groups working on engines, we see groups working on transport airplanes, small airplanes. We're seeing vehicles now that don't fit in nicely into those buckets, right? So that in itself drives the need for the FAA to fundamentally change away from that product focus. And what we've done in aircraft certification is move much more into a, we'll call it functional focus. And there will be a couple additional slides we'll put into the handout that lay out kind of the structure, but I didn't want to put org charts up on the screen for you all. But what we've done in July of this year, or last year, the FAA announced the air transformation reorganization of the aircraft certification service. And what that did is it moved away from that former directorate system into a series of, as I say, functional organizations. A couple of them really deal with our business processes and our measurement of our business organizational effectiveness. And then there are three that are really dealing with our core operational functions. I'm heading one of those, the Director of Policy and Innovation. What that does is brings together all of the regulatory development aspects, all the policy development aspects for the FAA certification, as well as our integration of our research and development activities, so that we can bring together and gain the synergies from the folks that deal with transport airplanes, small airplanes, helicopters, engines, all into one organization to really set us up to enable some of the future concepts, the future growth that is going to be coming from this industry, and ensure that our policies and regulations evolve into a framework that enables. Greg talked about the Part 23 performance-based rulemaking. That is a huge enabler. We see synergies in all of our regulatory environment where we can continue to leverage that performance-based framework more effectively and the like. Organizationally, the next part of the function is we did put in place a consolidation of all of our certification offices into an organization, certification and airworthiness, so that there's a better consistency across the FAA, the application. So my organization will be developing the policies and the regulatory framework, working with our certification folks and our next organization, safety oversight, on the application of those policies and regulations to the products and the various design and manufacturing systems that the companies have. And that is the third component of that organization, is a system oversight organization that does do that safety oversight with the individual companies on the production or engineering side. All in all, one of the key focuses we have, especially across the organization, across the FAA, is enabling the innovation that needs to occur, that is occurring. And so what we're doing is we are working very closely with all the companies, all the folks that are certainly on the panel, but take Mike's list, and I can tell you we're working with most all of those folks in some shape or form. Now, there's a couple aspects of how we're doing that. There's a concept that we're flushing out and institutionalizing called the innovation centers. The innovation centers, what those are to be about, really is the operational structure of how are we going to enable the regulatory policy changes at a broad level for all of the technologies that were in, for example, the Bell presentation. How are we going to flow those out throughout the product lines in a way that meets a continuum of safety based on the expectation for the type of product that is being certified. So we'd look at it at the macro level, but then working individually with each companies on the unique features of what their products are doing and how they're going to be operated, so that we're really driving hard with industry an early engagement model, where well before a company applies to have a product certified, we're having the very detailed discussions of what is the path to get this certified. And because each of these products, throughout the briefings, you saw tremendous variation in the concepts of the products and how they would be operating. Each of those products will have features that would be reflected in how we would intend to certify those, but what we would be doing it to a consistent safety standard, okay, to meet that public expectation. So having the detailed discussions with the companies on how are we going to enable these technologies in a safe and efficient way, build that into their certification program so that they can then move forward with their product and have some regulatory certainty that they can bring those products to market in a way that we can certify them. We're also working across the FAA to ensure that the operational aspects are covered as well. So with that, Mike, I'll leave it there and we'll move on to the next phase of this panel.
So the question is whether we can do this whether the FAA, I guess, can do this within 5 years.
Well, I think there's a lot of assumptions even in the question, right? I think fundamentally we're trying to work with the companies, with the industry, to meet the timeframes that they're trying to meet. Now, is the technology going to develop at the pace it's going at? To meet those, are the operational concepts and the other parts of the infrastructure going to develop in those timeframes? We're trying to match the speed of the industry, right, and not be the barrier. Now, that, as I said, there are a lot of challenges that will come down the line. Not just certifying the product, but having the operational approvals and having it work in the air traffic system and around the air traffic system. Those things still also have to be worked out. So I think right now we're all trying to move aggressively on that. I think the time frames remain to be seen if those are going to be achieved or not.
Can I jump in and add?
Yeah, and let me just also add, does it really matter? I mean, the real thing is this is not a matter of when, sorry, it's not a matter of if, this is when. This is coming, and whether it's within 5 years or 6 or 10, this is just really going to transform the world as we know it.
It matters. It matters to investors. It matters to the companies who are putting serious money into this. And we are very serious about starting in 2023. But your question needs to be decomposed, as was suggested, right? We can already do these operations with helicopters today at low scale. So really the fundamental question you're asking is, can these vehicles be ready, and can you do it at scale?
Correct.
Okay, so there's no question that we will evolve to scale, right? In 2023, you expect to have 50 aircraft from hopefully at least 3 manufacturers, right? We can do that. If we had 50 helicopters in Dallas, we could use those today, right? That's not really high scale. So the operations can be done. The infrastructure, can it be ready by 2023? No question. No question that can be ready. So really, it just gets to the core of your question, can these vehicles be certified by 2023? These new electric VTOL, so that we have much quieter, electric, efficient, high-speed aircraft as a differentiator from current helicopters. And that is a key question that we are aggressively committed to enabling and accelerating by working with the FAA, with the manufacturers. But there's clear paths through Part 2117, right? It's not an easy certification path, but certainly many of the manufacturers are going down that path as we get 23 ready to embrace fully all the standards required for eVTOL.
Sure.
Okay, so the question is about what kind of avionics future aircraft will have.
So I think there are really two different answers. There are a lot of technologies that are evolving out of the existing avionics supply base for aviation, who are aggressively moving forward, whether it's fly-by-wire, whether it's the automation of functions within the cockpit. But there's also a tremendous amount of activity going on in other theaters, whether that's automotive automation or whether it's technology companies in general that are doing a lot of work. Now, the stretch there is to be able to get to certifiable technology from some of those other industries. But the underlying pieces that you need in terms of the ability to do artificial intelligence, in terms of the ability to do the software development that's required and the infrastructure that you need to get that stepwise path from our federated cockpit all the way to autonomous. There are multiple different streams that are coming in, many of which are interesting, but the folks you would recognize are also pursuing the same paths. So it'll be interesting, but much like you saw a lot of new entrants on the OEM side of people who want to be the Tesla of our industry, that same thing is happening on the electronic hardware side. So I think that's going to evolve, and we'll see more over the next couple of years of how that develops.
So the question is about batteries and then whether it's limited to the 5 partners.
Yeah, so you may know we have the second Elevate annual summit coming up on May 8th and 9th in Los Angeles. We will be showcasing our battery strategy and how we're going forward in that area. As you probably know, we just hired a key Tesla expert to lead our battery development program. You will see that we are establishing a critical path that does 2 things. One, sets a lower risk path with known extrapolations of existing lithium batteries, while also advancing to the next lithium metal set of batteries and making sure that we can have the standards and also the safety requirements in place for that next evolution of lithium batteries to be able to enter the high performance aviation world. So that's the first question.
About the 5 partners.
Oh, the 5 partners? Certainly. Again, you look at these 52 companies, everyone has a different approach, right? And so it is the wild, wild west. Certainly, we want to support the development of these advanced eVTOL. I think it's reasonable that we would embrace additional partners, but I think also it's reasonable that over time you'll see us honing in on really deep collaborations with less than a handful, so that we can make sure those serious efforts are prioritized and that we achieve the best matching of what the vehicles are capable of with the operation capabilities that we need. And I just want to tag on to the last question where, again, GAMA's being a fantastic leader in this area. Even in the next 2 weeks, we're having a meeting that is bringing in the new aviation and autonomy companies to work this SVO strategy, simplified vehicle operations. So there's fantastic different interchange meetings that are happening that are bringing us all together and being a forcing function to make this happen sooner.
Can I tag on to that? Just getting back to the battery question for a minute, in terms of timeline and in terms of mission capabilities, certainly Uber's been very clear about their desire for all electric, but depending on the mission demand, one of the things that we see is the desire to start with hybrid electric. Hybrid electric gives you the opportunity to expand your mission set, and then as battery technology matures, certainly be able to perform the functions that Mark is talking about as we get down the road.
And I just on that, pretty much all of the standard turboshaft engine manufacturers have come out and said that they're also working hybrid electric technologies. So Safran, GE, Pratt & Whitney Canada, Rolls-Royce. So everybody's looking at hybrid electric as well. Okay, so the question is about hybrid electric.
Yeah, so So I guess there are different views on that. So you see people today pursuing maybe a smaller payload, smaller range, and going full electric. We believe that's possible. For Bell, our approach is to try to tackle the problem that we're really trying to solve, which is a fully functional, mission-capable vehicle. And if that fully functioning, mission-capable vehicle is 4+ passengers, along with a 40 to 60 nautical mile range, hybrid is a way to get there. Certainly there are mission sets that go beyond that, both in terms of payload and range that we find interesting, that use the same basic underlying technologies. And so hybrid is a way to get you to some mission sets that it may be a very long time before fully electric gets you there. And if you have a modular design from the beginning, then for those missions that don't require it, you can certainly be all electric.
So questions about safety and public acceptance. So Mark is chomping at the bit here, or?
Can I speak from here?
No.
Okay.
You might want to tackle the market size first.
Market size. We're doing extensive demand modeling based on the Uber data and cell phone data, which is publicly available through Streetlight and other companies, AirSage, anyway. Yeah, as we look at it, to be a meaningful transportation solution and to get to the economies of scale so that this is affordable to mainstream markets, inherently we're talking about any city having many hundreds and evolving to many thousands of aircraft. So while we'll start with 50 aircraft, very quickly within less than 2 years, we expect to be able to achieve 300 to 500 aircraft in a single city, with the intent to get to over 1,000 per city over just another few years. The economics require that kind of scale. To achieve a highly efficient network with high load factors, which are key assumptions in the economic modeling, you must get to that kind of economies of scale. So I want to actually talk much more about your safety question, because that's the more important question. Not only are these vehicles going to be inherently different and more capable in terms of safety, right? They will be designed in ways so that a single part failure cannot bring the aircraft down, right? And that inherent redundancy across the propulsion, the energy, all this, the control, all the systems, is a unique differentiator which we feel will make the vehicles much, much safer. But the safety burden can't just be on the vehicle. It's on the operational context of how they're used. And that's why you won't see us talking about flying into people's backyards. We're flying from skyport to skyport because that's an operational context where we can ensure very, very high levels of safety. It's a very well-known area. It's very well controlled.
So with that, we'll draw this to a close. I just want to thank you all for coming, and especially to thank our panelists today for speaking on this real transformative electric VTOL revolution.